Hey, this is Electronics Bit by Bit, and today we're going to be making a logic circuit. So before we start, I just wanted to let you know that this video is a continuation of an article I made called How to Make a Circuit with Logic Gates, and it's a quick 4-minute read, and it goes over all of the ins and outs of how a logic gate works, whereas this video is more about how to build the actual circuit. So if you want to understand how logic gates actually work, I recommend reading the article before watching this video. And the article has a list of all the equipment that I needed to make this circuit and links on where to buy it. So now on to the breadboard. So a breadboard is a piece of metal that is separated by bits of plastic so that the rows connect to each other but the columns don't. So putting something in A1 is the same as putting something in D1, but putting something in A1 isn't the same as putting something in A5. So then we have the power wells. There's power wells on both sides with a positive and negative side, and this is where we connect our power source. And the power wells are connected to themselves, but they're not connected to the other power well or the main breadboard area. So then we have to take a wire and move the electricity from the power wells to the breadboard. Next, we'll need our power supply, which is going to be a 4.5 volt battery pack, which has a red wire that's going to connect to the positive power well and a black wire that's going to connect to the negative power well. When storing a battery pack, it's always important to take one battery out of the pack just for safety purposes. Then we'll need a 100K resistor, two 1K resistors, and if you're trying to tell the difference between the two, just look at the stripes on each of them. Then we'll need an LED, an AND gate, and a dip switch, along with what I like to call bendy wires and bouncy wires. So first we'll talk about the LED. The way an LED works is it needs to receive a positive and negative current in order to light up. So it has this longer prong that's an anode, which is the positive side, and the shorter prong is a cathode, which is the negative side. Normally when you buy an LED, the prongs are really long, and so you may want to cut them with kitchen scissors for aesthetic purposes, but if you do that, just make sure that you keep the positive side longer than the negative side. So then I put the LED into the breadboard with the positive prong in row 45 and the negative prong in row 46. And the reason I say it like that is it's going to be important to keep track of where the positive and negative prongs are. So then I take the 100 ohm resistor and I connect it to the negative side of the LED by also placing it in row 46. Now the point of a resistor is to limit the current that can flow into your device to avoid it burning out. So the reason we're using a 100 ohm resistor for the LED is because we want there to be enough current flowing through that it shines really nice and bright, but not so much that it burns out. So now we apply the same idea to the dip switch where we set it down and then we add two resistors to it, but this time we're using 1K resistors. And the reason why is because the only thing the dip switch is doing is providing a small electrical signal that's going to be sent to the AND gate to be processed and put as an output to the LED. So it doesn't really need that much current flowing into it. So that's why we're using a larger resistor. So then we get to the star of the show, the AND gate. And if you look in the article, you'll find a diagram for what the inside of the AND gate looks like. But basically, this prong here is GND, which is going to be connected to ground. And then this prong up here is VCC, which is going to be connected to the positive power well. And then these two prongs are inputs, and this one is an output. The next two are inputs. The next one is an output, and the same applies for the ones up here. So the first thing I like to do when wiring is take my bendy wires and make sure everything is connected to the right power wells. And the reason I like bendy wires for this is because when there's something wrong with your circuit, it's very rarely the power connections. And so you don't really have to move them around or tinker with them. So it's nice to just have them flat and out of the way. And even if you do this step, it's still really easy to forget to connect all of your power sources. Like you see in the video, I forgot to connect the resistor to ground. But that's okay because you can still use bouncy wires to do the same thing because they're basically the same thing in different forms. So then I take my bouncy wires and I connect the inputs from the dip switches to the inputs in the AND gate, and then I take the output from the AND gate and I connect it to the positive side of the LED through row 45. Then I connect the resistor that's connected to the negative side of the LED to ground, and then there's my circuit. Now, if I'm happy with my circuit and I know that it works, I can always swap out the bouncy wires for bendy wires because I know they look better aesthetically, but it's up to personal preference. Now let's run through all the cases. We start with an input of 0, 0, and we get an output of 0 from the AND gate, so electricity doesn't flow through into the LED and it doesn't light up. The same thing happens when the input is 0, 1 and when it's 1, 0. But then when the input is 1, 1, we get an output of 1 from the AND gate, electricity passes through into the LED, and it lights up.